So I wanted to give you a sense of the different topics that we're going to handle over the course of the semester. The first couple of weeks we're going to spend on more preliminary kinds of issues. So we'll spend some time talking about Python. Some of you are coming into the class with experience in Python, and that's fine. Others of you are coming in with experience from other kinds of languages. So we'll spend time talking about some of the intricacies of Python. There are certainly some strange syntax things that happen, and there's some strange and interesting data structures as well. So we'll spend some time with that. We'll be using Jupyter. All of my examples will be done in Jupyter. This is a very simple IDE, integrated development environment for Python and other languages. We have a Jupyter server set up that you will be able to log into and make use of. Those details are coming soon. You are also, of course, welcome to use your own computers for this purpose. You can set up Jupyter on your own machines very easily. You're also welcome to use any of the fancier IDEs that are available for Python. Pandas is a package that comes packaged with Python. It is all about handling really tabular kinds of data. So it's easy to import, for example, CSV files, examine the data, massage the data, and manipulate it in very simple ways before we move on to more complicated things like applying machine learning algorithms. NumPy is our numerical package in Python, and it is all about very efficiently handling matrices, more generally tensors. We'll talk about what those are as we get a little bit further down the line. It handles sparse matrices, and it does matrix operations very efficiently. scikit-learn is a package that provides a very large number of different machine learning algorithms, and this is where we'll be spending our time over the course of the semester. It presents a very nice, consistent interface to many different algorithms, so it's easy to move your data from one algorithm to another and see how well it works. We'll also spend time on best practices in Python. As you're searching around the network for solutions to problems, you will find all sorts of examples that are out there. And many of those examples are not very good examples for how to program in Python. So we'll talk in the beginning a bit about what makes good Python programs. And over the course of the semester, I'll try and give you lots of examples of doing things reasonably well. We've already talked about this distinction between classifiers and regression. Classifiers, we'll talk about a variety of different kinds of algorithms, from logistic regressions and support vector machines to decision trees. Classifiers in particular are very interesting in that we can ask about which of the input variables are most important for making decisions. And this helps us really understand how the classifiers are working. So this is the topic of feature importance. On the regression side, you all have experience with linear regression. We'll talk about a variety of nonlinear methods as well. And even in linear regression, there's some challenges there that we'll talk about. On the nonlinear side, we'll talk about polynomial and, in general, kernel regression. There's also something called support vector regression, and one can also use decision trees to do regression for us. Decision trees themselves are pretty big topics, and one can have an individual decision tree that generates an output, but one can also build a forest of decision trees. So these are the topics of ensemble methods and random forests. On the unsupervised learning methods, we'll hit principal component analysis. Some of you already have experience there, but we'll then begin to generalize that type of an approach beyond what one can do on the linear side of things. And so that gets us into things like local linear embeddings, multidimensional scaling, and isomap. So all four of those are really techniques for taking data, in some cases in very high dimensional spaces, and bringing it down to a very low dimensional environment where it's easier to visualize or it's easier to apply existing machine learning algorithms to. On the clustering side, we'll study a couple of different algorithms, k-means clustering, and then we'll also spend some time with mixture models. And this is where we get into the expectation maximization type algorithm. And I've already hinted at these topics already, but we'll spend time on tuning models. So detecting and dealing with overfitting, how do we choose hyperparameters, and how do we compare algorithms, compare hyperparameters in a way that's statistically sound, so that when we walk away with a particular favorite learning algorithm for a problem, that we're confident that it's a good choice moving forward. So that'll get us to the very end of the semester. There's a lot for us to cover. Next, we'll talk about some of the mechanics for the semester.